sure that on a river site with those giant buildings doing massive activities, every one of those activities at some point were either invented at the laboratory or worked at the pilot level and then expanded to a larger size to be deployed across the site. We do the same thing with the rest of the complex as well. So it's not just the Savannah River site that we work with. And this last block here on fusion energy is just my placeholder to tell you, grab your popcorn. We're going to have a fusion energy video at the end of this discussion. So, as the site transitioning to NNSA, I've already established that we are an EM lab. We're integrated in everything that EM does across the DOE complex. I want to pivot from that and tell you what is it that we do for NNSA. Okay, so this will give you a bit of an inside view of the things we don't typically talk about, but there it is. So 3 directorates. Our directorates are actually aligned with our headquarter components. So one of my directorate is environmental management and legacy management. Obviously, it's a direct alignment with EM and LM mission. Another organization that I've got is global security that is very much aligned with non-proliferation activities. And the last one is weapons production technology that's very much aligned with weapons production activities in NNSA and nuclear deterrent. So to identify the preliminary supporters, NA10 supports the weapons production predominantly, NA20 predominantly supports non-proliferation activities. Then, as with any large organizations, NNSA has many other divisions within them. We work with them in different arenas, and I'll show you a couple of examples. The laboratory has 6 core competencies. The ones that are written purely in black, those were legacy core competencies, came to us from our activity sets within the Cold War. The blue ones are more modern activities that we are adding to evolve the laboratory beyond what we do, trying to preserve that multi-mission national laboratory working on modern technologies and modern research. So if I were to talk about the work we do for global security, within global security for NA20, NA20 is one of the big organizations in NNSA that is focused on non-proliferation. So we develop a lot of mobile systems that have to do with plutonium work. Getting beyond giant blocks of buildings that do things like plutonium disposition or plutonium dissolutions or uranium dissolutions, how would you do those on a smaller scale? Well, we design things that can actually be put on trucks or ships, be transported, and have the same level of capabilities. Packaging, logistics, and transportations. One of the things we do on behalf of the Department of Energy is that we design and certify packages that allow you to carry nuclear material or waste within those packages, and they're certified with Department of Transportation. Technical support to H-Canyon, as you heard from Mike Budney, H-Canyon is actively dissolving materials, and as they come across unique samples or unique targets that they have to dissolve, this is where we really get engaged with them. So the fast critical assembly that was mentioned earlier, that's one of the samples that have to be dissolved in an unusual way. We worked with H-Canyon to make sure that that process can continue on. Asset utilizing Mark 18, I'm going to show you 2 slides on that later, so we'll go a little bit more detail. Continuing on, for sensing and characterization competency, we work with environmental sampling and analysis. We help the Department of Energy as well as the international communities to validate that the non-proliferation regime is adhered to and nobody is cheating on doing things like producing nuclear material and testing them. Continuing on, we have a whole organization that looks at cybersecurity and connected system. Cybersecurity, that's kind of an overall thing that everybody does, but our work is focused on operational technologies, preserving the ability to transmit secure energy without our adversaries having a negative impact on it. So a lot of our cybersecurity is focused on physical security, grid, as well as the interconnected systems. NAIM is an organization within NNSA, that's for information management, so think of it as a large IT organizations. Every year we work with NAIM to run a number of exercises for them to ensure that in fact that cybersecurity and physical security for connected systems are preserved and tested under different conditions. So we do that typically at our facility at Georgia Cybersecurity Center, University of Augusta. For the cybersecurity and its impact on grid and energy, we focus on customers that require national security, defense, critical infrastructure, and industrial bases. At the end of the day, energy transmission is important to our federal government, to public at large, and industry base that uses that energy. Everyone uses that energy in a different way. They have different control systems. How do you preserve the ability for those systems to work unhindered? So continuing with NA20 programs, NA21 is one of our sponsors that focus on global material security. NA22, we work with them on non-proliferation, with 23 with material management and minimization, and NA24 with non-proliferation and arms control. All of this information is available on our websites. If you want to dig a little deeper into any of them, we have a fantastic outside-facing website that has some of this information available. Now, I told you that I'll tell you a little bit more about Mark 18 and asset program. Well, Mark 18 is a target, irradiated target, that was irradiated decades ago and was stored in El Basin. What is amazing about this target, it has the world's only quantities of plutonium-244 that's built up in this target. Plutonium-244 has several key applications for us. One of them is forensic analysis that we do. And this target that's been sitting around for decades contains roughly about 20 grams of plutonium. Now, when you have a target and you want to dissolve it to extract that 20 grams of plutonium, 20 grams of plutonium sits at the bottom of a glass. If you imagine if you have a 2-ounce shot glass, this thing fills roughly half of that shot glass. Meanwhile, these nuclear targets are very tall and very large. So if you were to dissolve this in a place like H Canyon, it's almost impossible to recover that plutonium-244 from the dissolution process. So we had to establish a brand new process within the laboratory that takes these targets into hot cells, cuts them, dissolves them, purifies them, and then extracts that 244. Then we send it to Oak Ridge National Laboratory for the isotope to be isolated, and then we send it back to the Department of Energy for its application. Seems like a simple process. It's actually a multi-year project because every atom of 244 that we dissolve is so important that we want to collect every atom that we dissolve. So this is a very involved process. Now, on top of this process, because there's a lot of different chemistries, engineering, and physics that's involved, and we're starting the project, a lot of the expertise have left the Department of Energy over the past few decades. So we're also using this as a teaching opportunity with our early career scientists, and that program is known as the ASSET, where we bring these early career scientists to work alongside Mark 18 and understand every aspect of nuclear material processing and nuclear material extraction for useful isotopes. This is the first opportunity we have had in a long time to bring the early career folks on and teach them new processes in nuclear material processing. We support international community. As a member of IAEA, this is the International Atomic Energy, we are the only laboratory that produces standard nuclear particle for IAEA laboratory to validate the samples they collect around the world. What is lacking in a nuclear world are specific size particle with known composition of nuclear material, and they're very difficult to produce, and the laboratory that does that best for binary systems is Savannah River National Laboratory. So we are one of the providers of nuclear standards to IAEA. One of the great advantages we have being in Savannah River site, 310 square miles of heavily forested area, industrialized area, ponds, we got swamp, we got different geophysical characterizations within the site that we can utilize. So we use the whole site as an experimental facility, both for EM and for the rest of the federal government. So what I have shown here is a network of different things around the site that they're all pulled together under advanced technology proving ground. So we do a number of things that involve cybersecurity. We look at grid and the effect of potential things like EMP or radio frequencies on a grid. We look at the potential dispersion of radiological material. We look at things like how do you identify timing elements on grid to make sure that that's not in any way interfered with. We develop a lot of sensors. We work with both Department of Defense, National Guards, both in Georgia as well as South Carolina, to do a lot of training and exercise. We have one of the only licenses for flying drones beyond the line of sights, as well as working with wireless and 5G around the site. So lots of different capabilities that the government as a whole can use, and we do a lot of training for the federal government in the areas that really interest them. On a weapons production side, the laboratory is known as the technical authority for tritium production. So we are engaged with the Department of Energy, NNSA, as well as Weapons Laboratory to ensure that things like the gas transfer systems are designed and work appropriately as designed to do. So we perform R&D with the design laboratories, this is Los Alamos and Sandia, to make sure that the design for gas transfer systems are in fact workable. We provide the Savannah River site with tritium processing. Anytime there is a potential issue within a tritium processing plant, the laboratory is a key player in making sure that we can continue production, purification of tritium, and continuing our processes there. Finally, I'm just going to point out that we do a good amount of tritium R&D with regard to material compatibility, and I'll show you a couple of examples of that as well. So within tritium technology, we do have a capability for material and testing facilities. Tritium, deuterium are isotopes of hydrogen. So hydrogen, if you look at the periodic table, the first element, the most abundant element in the universe, hydrogen, has two isotopes. One of them is deuterium, the other one is tritium. Tritium is what's used in the nuclear weapons. Hydrogen is that energy source that everybody's after, because if you can harness abundant hydrogen, you can have clean energy, and the byproduct is simply water. The amazing thing about hydrogen, because it is also very small, it interacts with almost anything. It can penetrate metals. Well, the same thing is true about deuterium and tritium, except tritium is also radioactive and it decays. So when something impregnates a metal and decays, it has a completely different impact on that surface and that material. All of that research is done at Savannah River National Laboratory to ensure we're doing the right thing. So a lot of material technology, a lot of new sensors. The fastest hydrogen sensors currently in use is invented by one of our lab PIs just a few years ago. And as you work with these challenging environments, you need advanced engineering to be able to make these tools to go forward. Continuing, surveillance of existing technologies and components. We do a lot of hydrogen and tritium effects. One of the byproducts of tritium is helium-3. It's an extremely rare element, and it's used in nuclear detection as an exquisite nuclear detector. So when feasible, we work with tritium facility to make sure that that helium-3 is extracted and then put back in the community for scientific use. Tritium science and advanced characterizations, we work, again, with the tritium facility, looking at all different components that this tritium can interact with in different ways. As a consequence, we need to have a series of research that focuses on things like metallurgy and welding, because now all the welds and metal alloys are affected in different ways with this surface chemistry of tritium, hydrogen, and deuterium. Do we understand that well? Well, that's a part of the research we do every day. Fracture and mechanics. So an example that I have up there, it's 3 different rods that have been either not exposed to tritium for 6 months, 18 months, and the last one exposed to tritium for 60 months. And metals are malleable, and as you pull them apart, they should kind of narrow down in the middle and then break. You see that on the first plot on top, right? You get 2 sharp ends because as you pull the metal, it's like a taffy. It kind of give you that little sharp end, and then they break apart. The difference is when you expose it to hydrogen, because hydrogen can penetrate it, it really makes it brittle. So you can see, in the case of 18 months and in the case of 60 months, you get a completely different fracture. Well, it may seem trivial, but when you have it in a working system, it becomes really important whether you're generating hydrogen for energy applications or tritium for nuclear deterrence. It's very important to understand the material characteristics working with these type of elements. The new plutonium processing facilities that's coming online at Savannah River site, we're working very closely with them on a number of different projects. This is the kind of a flow chart of the things that needs to be done at that facility. Notionally, the base plan is to use Los Alamos National Laboratory's technology within that plutonium facilities. But even you're using the same technologies, as you're implementing them in new facilities, everything has to be tested and validated to make sure that it's in fact going to work the way it's intended. So we have 3 different projects currently with Savannah River Plutonium Processing Facility. One of them has to do with how do you convey that nuclear material? How do you move them about in a facility that's that large? So that's a conveyance system. We're looking at casting and pyrochemical processing. These are the ways that you can work with plutonium metal to make sure that you get them into the final form you want to use. And finally, there is a hydride, dehydride system that allows us to remove plutonium from a substrate that the plutonium is attached to. So if you want to remove plutonium without getting it contaminated, how do you do that? So those systems are either developed by Los Alamos or by Livermore. They're re-implemented by us on site to make sure, in fact, it's going to meet our daily needs. So, because we are in the middle of it, both with EM and NNSA, we are a laboratory that can increase the bandwidth of the community that we work with. So in this case, for NNSA, we work with Livermore and Los Alamos on very specific projects. We have some of our scientists sitting within different commissions and committees that NNSA runs to make sure that we actually have a voice in that community. You can see all the things that we lead on behalf of Savannah Riverside within NNSA. So with this, I'm going to pause and ask for my second video to be shown. And that video actually has nothing to do with this stuff that I talked about, because as a multi-mission national laboratory, we have different things that we do for different parts of the Department of Energy. So the next video is going to show you that Savannah River National Laboratory is the leader for tritium fuel cycle.
Imagine a carbon-free, dependent on radioactive waste. The sun and stars, but for a commercially viable, create an operational fuel cycle. Laboratory comes in.
That collectively energy sources to the grid. What Savannah River National Laboratory is exquisitely good at is separation. And because our laboratory is an expert in tritium, you need for a fusion process.
So it tries to mimic that natural.
Another reason that it's important, the Department of Energy announced the bold decadal vision for fusion to have a pilot plant for fusion within the next 10 years. And it's essential that we develop those technologies, get the technologies ramped up and designed now.
Help realize fusion energy commercialization, SRNL researchers are advancing technologies, materials, and process efficiencies in the deuterium-tritium fuel cycle.
In the fusion program, chemists, engineers, scientists, we have PhDs, masters, bachelors, and all is needed. And it has been very exciting to put towards the whole vision that we want to how to bring fusion to the US grid.
SRNL performs fusion fuel cycle modeling to optimize system design, monitor operation, control
experiments, you can guide design decisions for experimentation to start getting this information to improve your models and improve your ultimate design decision on the back end, because you want to try and get as close to the final design as possible when you build your pilot plant.
Developing and characterizing durable materials that can be exposed to hydrogen, deuterium, and tritium is another challenge in the fusion fuel cycle.
So we are trying to understand how tritium affects the properties of different materials, and also how it moves through materials and where it gets trapped and avoid environmental release.
SRNL developed a patented process cycle to detritiate pump oil in common vacuum pumps.
We're trying to find ways to adapt existing commercial pumps and make them work for fusion energy. So we're looking at, the molecular structure of oils and trying to find the ones that work best with tritium, because tritium is very destructive towards its materials. So we're actually using organic chemistry.
SRNL is also leading the development of the tokamak exhaust process, demonstrating grid-scale fusion feasibility in France.
ITER is potentially a historic project. It's the first large-scale machine to prove that power can be supplied to the grid from a fusion device. Also, workforce development and the future fusion community. The tokamak exhaust process. We're developing the future for fusion.
Outside of the SRNL campus, the Fusion team is collaborating with companies, universities, workforce development partners, as well as other DOE national laboratories. Savannah River site, which includes pre-approved tritium inventories, exceptional site characteristics, and defined environmental analyses, can also further fusion commercialization.
I think the opportunities here at Savannah River are limitless. I think there's opportunity to actually build big things at Savannah River. We have 300 square miles of government property here where we can locate nuclear facilities, such as a laboratory capabilities for testing new components for nuclear fusion.
Fundamentally, the laboratory is really the birthplace of the fusion fuel cycle. But what makes scientists in early career, mid-career, and senior scientists with vast subject matter expertise, all working as a team to solve this very complex problem that affects our nation as a whole. That's a part of being a multi-mission national laboratory. The Department of Energy has a broad set of complex challenges, and we all get engaged in solving very nationally complex problems. So in the case of fusion, we partner with Princeton Plasma Physics and Oak Ridge National Laboratory as two key partners to developing these systems that ultimately is going to end up in France as a problems are so huge that no one national laboratory has all the skill sets you need. But with us partnering with other national laboratories, partnering with universities, and with private entities that have problems. And that's why I'll be happy to have those problems and the projects that we have around them come to you for presentations over the next few meetings so we can focus on specific areas. Again, I was trying the laboratory does, but we do a lot of amazing things on nanomaterials with advanced manufacturing, 3D printing, or one of our partners that we're working with. So with that, I'll be happy to answer any questions.
Let's start with Mr. Hartley here.
Yes.
I'm Nate Hartley, KL, where you get your tritium from, but tritium is a radioactive isotope, so you get it from there. Is that correct?
So the tritium that's produced in the United States comes from what's known as TP bar. These are tritium production bar. As a part of this partnership is Pacific Northwest National Laboratory. So PNNL designs these TP bars that's being manufactured by an industrial partner, Those TP bar goes to a part of Tennessee Valley Authority nuclear reactors. It gets irradiated, acted, and purified, and then that tritium is used for U.S. applications.
Okay, and then what is the purpose of particle production and what do you use it for?
So the particle production, that particular example, we create reference particles so that so as the IAEA samples around the world and collects particles, they do a comparison and can identify if the particles they collected has plutonium, uranium, or other radiological compositions. But to do that, you need a reference material to test it against. So we produce that reference material so that it's being produced by a proliferant or is just a natural byproducts.
Okay, thank you.
And we'll just go right next door to Scott.
Good afternoon, Vahid. I was interested in that 10-year fusion goal versus your pilot that you talked about.
So let me talk about ITER program, because ITER program, they're rebaselining, and one is the first plasma experiments are designed. You know, if you look at the announcements, Lawrence Livermore able to create fusion using lasers or inertial confinement systems. ITER is what's known as a magnetic confinement system, completely different in its design. And as a partner for ITER, we focus on, imagine if you think of fusion as an internal combustion engine that is going to burn some gas, everybody by making it more efficient. We're focused on how do I get this fuel into it, be it a carburetor or fuel injection, all the impurities so I can reuse some of the fuel back. So that's the exhaust system that we're designing for ITER. So ITER is going to be operational, I'm just going to say, not knowing their baseline, sometimes in 30s. And that is the best hope production to meet energy needs, or certainly the research for energy needs. There's more than 20 venture capitalists and companies working on fusion. Like any new companies, not all of them will be successful. We have a non-disclosure agreement and a work agreement with at least half of those companies because of our interest in fusion fuel cycle. The commercial industry cross-section that's really interested in working with the laboratory and use our technology. So going back to your first question, when is it going to be on the grid? I really don't have an answer for you because we're still in the evolving portion of this research to make sure in a consistent manner. Sorry, Scott, that was too long of an answer for a quick question.
Shade.
Hello, Shade Shofadia, SRS CAB. I'm curious about what instruments you're using for environmental sampling.
It's a whole wide variety of it. So
I'm more so interested in as far as like air quality.
We don't do air quality sampling at the site. We design air quality sampling as a part of the research. So for example, there is a building that EM at Oak Ridge site. And this building because of the many decades of work with mercury in there, it has a concentration of mercury that's embedded in the walls. And depending on the temperature, humidity, this mercury concentration in air is the lowest when we have workers going in there appropriately with PPE trying to decontaminate the facility. So the sensors we design are for those type of application rather than a normal air monitoring. So we work with a site that works with both EPA and DHEC, that they have all appropriate sensors and permits that are within the site. So I'm going to duck back and ask DHEC and EPA perhaps to help with some of those data that they get on the site permits. Or Mike, did you want to chime on this?
Well, I don't personally know exactly which. That we, the National Lab, don't do air sampling. We, the government, do sample air. We have a lot of air permits with DHEC, and we sample to make sure we meet all those requirements, whether it be the discharge from the biofuels plant or the stack coming out of the tritium facility or one of our other facilities. I would have to get with our experts to find out exactly what instrument we're using.
Yep.
Okay. And to be clear, you're only sampling indoors inside of the facilities, or is it the entire site outside?
So lots of different projects. We have an entire project in the F area that we have sensors embedded in the movement of plumes underground. It's a suite of large number of sensors. The data is then taken from those sensors, put through a number of AI filters. So we're using that to identify where the plume may move based on weather, rain, temperature, pH of the soil. So that's one suite of sensors that the laboratory is working with the site to make sure we understand what happens to underground plume. Air and temperature sensors across the site, there's a number of towers that we have sensors connected to them, measures things like humidity, particle density, work as an element of the site that determines if there's going to be a storm, if there's going to be a rainfall, because we have a lot of work, a lot of people that work outside the building in the fields, and they need to understand what the weather conditions are, right? So that's a part of the work we do as a service to the site. And then when it comes to other type of problems, so we just don't design anything for a purpose of designing it. There's always a need for something specific, and we're trying to look at that problem set and design a set of sensors and or filters for it.
Cool. Just interested in how you guys are measuring the amount of pollution, or just what other chemicals are perhaps expelled into the.
Again, the site has a number of different sensors that measure that, so I can't really talk about all the sensors because I simply don't know everything that we have in our suite.
Okay. And well, you guys do like a variety of research, and you're stating that you guys engage in research outside of the Savannah River site. I'm curious about like your future plan for the SRNL, like once the site is decommissioned. That laboratory, is there like an intent for it to be closed, or will there be continuing research?
That's a great question, because 3 years ago, Savannah River National Laboratory became an independent national laboratory. The Department of Energy, EM, looked at the horizon of the site, recognizing by 2035 or a little bit later that the site closure mission was going to be near complete. And to create that enduring national laboratory, they spun us off as an independent national laboratory. So regardless of how the site evolves, we're going to have EM mission for decades across the entire DOE complex, right? So that work is going to continue. I've also demonstrated that we have a very significant portfolio within NNSA, right? So that work is going to continue. And the work that I've shown on the things we do on a fusion that has to do with Office of Science or ERE offices within DOE. So as a multi-mission national laboratory, we work on a number of different programs. Even when the site achieves its sunset for EM missions, there's going to be a lot of work left in DOE to do, and that's what the laboratory does.
Are you guys currently doing any research? I'm curious about the research you've engaged in around biodiversity and pollinators.
So there is a Savannah River Ecology Laboratory that runs the background ecosystem for Savannah River site. They do lots of cool research. I have one joint project with them, and that has to do with the stress for hooded turtles that live on the boundaries of Savannah River site. And believe it or not, that's actually funded by Department of Defense, because it's the same type of turtles that happen to be in one of DoD sites that they're interested. So not a mainstay of the laboratory, we just happen to have the tools that allows us to do the analysis for the impact on the turtles. But Ecology Laboratory perhaps is the one that you want to hear from one of these times to tell you about all the cool stuff they do on the site that looks at all different type of animals on the site and how they work with them.
That would be cool.
Yeah.
Thank you.
They do great talks, and I'm always mesmerized when they show you the work that they do around the site. One of our partners, but in that case, that's the one you get to talk.
Thank you.
You bet.
Greg, you have something to add?
Yeah.
Yeah, Greg O'Quinn, South Carolina DHEC. Just want to kind of follow up on the question that she had. As far as the permit, they do have a permit in place. I don't know if I can speak to the specifics of that permit and what the requirements are and the constituents they look for, but I know that you've probably seen our ESOP presentation for the environmental monitoring that we do. And so we do have some air stations set up for the radiological monitoring. We do look at tritium. We do have, as part of those stations, we have a component that looks at tritium specific and some other radiological constituents. So that's kind of how we do some of the monitoring on site and at the perimeter of the site, the radiological aspect. And that's non-regulatory. That's not really associated with the permit.
Thank you.
Yep.
We'll come all the way around to Michelle.
Michelle Bush, CAB. First of all, I'd like to thank you for your presentation. It was very comprehensive and concise, and you covered everything and very clearly you did that. And so I thank you for that. Thank you. So mine is not so much a question, but a suggestion. As I followed through on the PowerPoint presentation, there were a lot of acronyms. So my suggestion is this maybe include a glossary with your PowerPoint. I don't know if Cab, Amy, if you guys want to just have an overall, but I do know in various places of the site what that acronym means in one place. It does not necessarily mean the same thing in another.
Yeah.
So just a suggestion.
You bet.
Thank you.
Sure.
Thanks, Michelle. And we'll come around to Candace.
Candace Cave Cab. Wanted to say that I've been on this cab for several years now, and I think your U-shaped chart that kind of explains the scope of what you do, probably the most useful that I've seen in a while. Because for me, I always wondered why there were so many different types of labs associated with the site. And so this makes perfect sense because you are focusing on the deployment of technology. So not so much ecology, environment, and things like that. But also, I think my main questions are coming from the Mark 18 program. I'm always concerned about risks and things like that. So I do have a few questions about that. So where are the targets stored? I know you said they're large,
Sure.
but the actual plutonium is small. So where are the large
Target stored.
targets stored?
They're in L area, L basin.
So are they are shipped to SRS? Is it a similar setup to the, I guess it was like the True Packs or something like that? Is it that type of situation?
Yeah, it's actually a specially designed canister for Mark 18 because they're not standard targets. So there's a canister specifically designed. Remember, as a part, we were talking about package certification and all of that. So it's a certified package that's used to transport the targets from L basin to A area, which then goes to our hot cell, behind our hot cell. With a robotic arm, the targets are introduced slowly into the hot cells, and then it goes through the processing of them. So they get cut into sizes that can be processed, and then it goes through a dissolution process, then it goes through a separation process.
So how long does it take to do the full separation or dissolving of one?
This is a long-term project. So because we only cut small portion of the target, and then we dissolve it, and then we go through the separation, we do that sequentially. This process is going to be going on for a few years.
Can you quantify that? So would it be like
I've got to check out the schedule to tell
10,
you.
20 years?
No. It's I have to really look at the dates to tell you how much, but it's less than 10. I can tell you that for sure.
And it says that they're the only remaining ones in the U.S. So are there others out there in the world somewhere?
Mark 18 targets? That Mark 18 is a very unique target that was irradiated in a very specific way to produce the constituents you see. So the 244, that's all that's left.
Okay.
Nowhere else.
I guess my question was, I was trying to get at was, is there the potential for other locations to send things here at some point in the future? Is somebody looking at and they're going, oh, they're doing this well at the Savannah River site.
Yeah.
Can we send ours there too?
Well, certainly not on plutonium 244. If there is an interest in separating other isotopes, we have to work with the Department of Energy to see what the boundary condition for that work is. I can tell you the Mark 18 is the only targets that we have in the L basin. Nobody else has anything that's similar to it. So the project was specifically designed for Mark 18.
Thank you.
Okay. And then Phyllis.
Phyllis Britt Cab. I'm still trying to understand exactly how SRNL functions as far as you have a percentage of things that you do that are totally outside of DOE, everything related to.
No, we work, and that number varies from year to year, but roughly about 15 to 20% of our work is outside DOE. And again, I have to get you those specific numbers, so you take that with a grain of salt. We work for other government agencies within federal government. So for example, we host a forensic laboratory for the FBI. So we work with the Federal Bureau of Investigations and Justice Department, and that brings in funding for a portion of our work. We work with Homeland Security. We work with Department of Defense. We work with the intelligence community. So we do work outside of the Department of Energy. But we're a Department of Energy laboratory. That means any money that comes to us through other sources, they go to the Department of Energy and then they get shipped back to us for that particular work done.
So how do you get those jobs?
We understand what the problem set within government, technical problem set or studies that government needs done. Because we do have classified facilities, some of those are only available in particular channels that we work at. Also, our sponsors outside the Department of Energy knows the capabilities we have. Because they know our subject matter expertise, they directly come to us with a problem set, and they ask us to solve those problem sets.
One of the reasons I ask is I know someone who works, he runs a small lab within the lab.
Yes.
And he was recently told that he was going to have to find his own work. And I don't understand how you do that when you already have a full-time job.
Yeah, that's actually, it's a telephone game, so I'm not sure exactly what you heard. What I can tell you is that we've got a lot of unexecuted work that needs more people working on them. So last year alone, we added 90, since the beginning of the fiscal year, we added 90 people to the laboratory to execute the work that we have still needing to be done. So I don't know that particular case. What I can tell you is that give that individual my name and have them drop me an email, because there's a lot of work to be done. And as long as they're willing to do the other work, then it can be done.
Gotcha. Okay, thank you.
Absolutely.
Any other questions from around the table?
Mike?
I just answer your question too, Phil. So all the national labs, they maintain a record of which have unique capabilities, and that's available to all the government agencies. So it's not just word of mouth, it's a written record. Science, I think, takes the lead in running that. And so people know where to go to get work done. Often they'll put out requests for proposal, and the labs will compete for the work when they have something that they know more than one lab is capable of doing. So it's a pretty good, well-rounded system. Everybody knows what can be done and where to go. And also for Sade, is gone. Oh, she's still here? Hey, so your question on air sampling, there's a lot of information in the ACER report. You may look there first. And then if that doesn't answer your question, we can get some folks, because I don't think it goes down to the detail of what sort of instrument is used exactly for the air sampling. But there is a section on environmental air sampling. There's a section on radiological air sampling. So a lot of information in the ACER report that you can see online. And if that doesn't answer it, we can get somebody from SRS who does that sampling to explain exactly what the instruments are they use.
Yes.
Right.
SER.
Yep. We would publish it each year, and they're all on the SRS website.
And just the three systems we use often at the laboratory for our activity sets, we either use molecular sieve for gas sampling, or we use filters for particle samplings, or we use cryogenic samplings if you want to do rare gases in air. That's pretty standard suite of equipment for air sampling.
Pat?
Just curious, if you get this additional work coming out, and I assume a lot of it's time sensitive and everything, and how do you plan and program monies for additional employees to do all this stuff?
If you get large programs coming in that are multi-year programs, for example, tokamak exhaust system for ITER, we know that's going to be a program that's going to be going on for the next eight years. You have to hire people to come and do it. So in other cases, when a program is ending and a new program is coming along, then you're trying to shift those personnel from program A to program B. That's why when we do our hiring, we're trying to hire people with a broad background. Because when you hire people with a very specific focus, it's hard to move those people from that very specific focus to a broader area. So the typical employee that comes to the laboratory, even on an early career, they have had experience somewhere else, and then we'll ask them to do something completely different from that experience. It's unlikely that their experience exactly matches what we do, but they've demonstrated flexibility that they can move from project to project.
Okay. Scott?
Hey, just a quick question. I was interested to see if your CPS work covers the whole DOE portfolio, or is it mainly just radioactivity?
No, we cover a broad range of work at DOE. We have a whole line of research on nanomaterials. We have a whole line of research on recycling, upcycling of plastics. We've got a whole line of research. We've taken the researchers that did all the fundamental work for glass manufacturing that ultimately went to defense waste processing. Those glass scientists and ceramic scientists, they had formulated a lot of different glasses, and that process is going. So we took those folks and focused them on what's the next generation of things you guys are going to be doing with glass. So they came up with cellular magnetics and foam glass that actually has a lot of different applications. So it's not just radiological, it's a broad spectrum. How do you use the skills you have in-house to address new problems and challenges? And again, I'm not doing it justice. I'm only naming tidbits of programs because the number of programs are quite significant at the laboratory. I'm telling you the ones that I deal with all the time.
Thank you.
Any other questions from around the table? Thank you so much.
James, thank you.
All right. Let's knock out a little bit of CAB business first. We're going to do an election for administrative and outreach chair. I'm going to pass out ballots. It'll be really easy. There is one person nominated for ANO. You do have the ability to write somebody in if you'd like, but I'm going to hand these out, and I'm going to immediately come back and start collecting around. So decide quickly. If you would, fold them in half for me after you complete it, though. We will preserve some element of anonymity to this vote.
This is how it happened.
Once you have completed it, if you would, go ahead and pull out the draft recommendation from your packet.
I didn't get to vote.
You can vote. I love it. Every now and again, Kim, you do something that makes me feel like you're my favorite. And if you will look through those real quick and confirm what we all know to be true. Okay, so we have a draft recommendation. This came from the chairs meeting that Phyllis and John went to. Now, I'm going to let our new members know and remind all of our returning members that these are a little bit different from what we typically do with a draft recommendation. When it originates from this board, we'll edit it until the cows come home. That's what we're here for. We want to make sure that it's polished and perfect in exactly the language that you want. This has been polished by the chairs of the EMSSAB already. This is the language. We cannot edit it. You have to give it either an up or down vote tomorrow. So if there is language in here that you cannot live with, that's okay. It just means that your vote's going to be no tomorrow. All right? So we can have a discussion. We can debate this. The one thing that we cannot do is edit this draft at all. Not even a comma. Okay? Any questions about that? You here? Could you, let's microphone it. Yeah.
Wasn't this being done already? I mean, the government and keeping records seems to go together.
So the records part, yes. What this is about, and I'll give you the Cliff Notes version, but I really need Phyllis or John to chime in because they were part of the discussion, is that they are looking at revamping the national EMSSAB website. And I mean they as in IT technical folks. They would like a limit on the amount of information available on that national website, as in how far back should it go. They don't feel like it needs to, the tech folks don't feel like it needs to be a long-term repository of data. There are differing minds about that, and that's where this comes from. Phyllis, can you give us a little more insight into this?
Yeah, I'll just say, we had a lot of discussion about that because obviously we want to make sure that all that information is available, but the view was that you didn't need all however many years. I guess if our cab started 30 years ago, it may be 30 years worth of recommendations on the front page, essentially, of the website. And so there was a lot of discussion about how to handle that, and it was finally decided that the solution would be a searchable archive online that you could access fairly easily, but that wouldn't, I guess for a better term, clutter the site itself. That you could go there if you want, if there was something you were really concerned about. Kind of like what we have done with our own, as far as we decided last year, the year before, that recommendations, we wanted a regular update on recommendations that had not been dealt with or had not, that we hadn't seen the conclusion. And I think that's part of it, is people wanted to be sure they could find if something was ever dealt with or if it's still sitting out there, that kind of thing. Don?
John Thomas Cab. Yeah, the goal was having it searchable, like Phyllis had said, because today it's chronological. So if you are looking for something, you have to go in and search. You have to either know the number or you just look through everything. So this will make it searchable.
So, Hubert.
Seems to me it should be kept and available at least the half-life of plutonium.
Which isotope, Hubert?
244.
Isotope of plutonium were you referring to?
Mike, I'm a historian.
Candace.
I got a question.
I guess it's more of a comment than a question. So I just want to be clear. What they're trying to do is make sure that all of the site-specific advisory reports, those specific types of information, are in one location, searchable,
So
digital. Like,
yes and yes. It actually would be in a second location, technically.
But there's
so
a
this
link.
So this is referring to the EMSSAB webpage. Like we said, there is actually online a searchable database for all FACA board activities, not just the CAB, but anything that falls under the Federal Advisory Committee Act. You can go and look up and find who the current members are, what they're working on, what the their past recommendations. All that exists in this database online already. Now, did you know that that existed before today?
I did not.
Hence this.
So this is essentially trying to make it easier. There's gonna be like a tab button, and you can go and access it like that.
Right. That would be the thought behind it. Pat?
Yeah, well, I'm just curious that, things that are relevant, do they go back 3 or 5 years? And then if you really want to get into the, I don't know how it's all maintained, the level of specificity and everything, and how it goes together. But you would say, like, over the last 3 to 5 years, I want to be able to search this immediately. And if it goes back past that, it's make it somewhat more difficult, I guess.
Yeah.
Historically, you know how.
Phyllis.
Just to clarify, these are only the recommendations that the Chairs Committee created and approved. This is not a searchable site for if you wanted to see what happened in Portsmouth SSAB through the years. You'd have to go to their website. This is only, and they're like 1,700 of life of the Chairs organization, but it's only those recommendations.
Yeah, so it's not each individual board's actions, it's just the chair's recommendations and responses to those. And so ultimately it comes down to, do you feel like this is useful? How much do you believe that? Any questions, comments, concerns about this draft? You feel like after a good night's sleep, you'll know how you want to vote on it tomorrow? Anybody unsure and need clarification on anything? No? Okay. That brings us to public comments then. Is there anybody here who would like to make a public comment today? Okay, seeing none. Amy, you brought your microphone very close. Well, not very close, but.
Because I was going to tell you who the winner is of the A&O.
I would love to know.
You want to know that?
I do.
Am I going to be, you're filming me? Wait a minute, let me get my.
I hate to break it to you, but you're on YouTube right now, actually.
I know. I was joking.
I know.
So the new chair of the A&O subcommittee is Sade Shafidia. Congratulations, Sade.
All right. That brings us to the end of our agenda for today. Are there any last questions, comments, concerns? And I mean this sincerely. I think somebody asked me once, you're just wrapping up, right? No, I legitimately mean it. If you have any last thoughts that we need to share, that you need to get out to feel like that today was useful to you, now is a great time to do it. So does anyone have any questions, comments, concerns that you want to discuss with the board before we call it a day? Seeing none, I'll see you folks. Oh, Nate, yeah. I'm sorry, these new cards, I'm not used to seeing them yet, so they're catching me off guard.
Nate Hartley, CAB. How do we go about signing up for a subcommittee?
We're going to send that out via email, and you just respond to it. All right.
Carlos Cato, CAB. Yeah, I just want to give a quick shout out to my mom, whose voice was featured on the video we watched earlier. I don't think I'd be a good son if I didn't do that.
All right. Candace.
I would just like to make everyone aware that today, International Bee Day, BEE, it's World Bee Day. Save the world, save the bees.
Right on. Before everybody picks up and leaves, CAB members that is, I need y'all to follow Miss Audrey outside. She's going to take y'all's group photo today. Audrey, wave your hand for him again, right there in the back of the corner. Everybody who is a board member is going to follow Audrey, and we'll see the rest of you at 8:30 tomorrow morning. Thank you.
That was a good deal.
So Nate, I've never met a webmaster.
I assume we take our stuff with us.
Take more material off the web.